So, that was a little loud. So thanks for picking this session. So every so often, the technology comes along that really changes how you do things in very surprising ways. So for example, back in 2004, I started using the Spring framework. And at first it was just because it was a simpler, easier way of doing development than the enterprise Java Bean standard at the time. But then after a while it became apparent that Spring really transformed how you did development. Testing became a lot easier. Development just got a lot faster. Things were just very different. And in the same way, I started using cloud computing a few years ago, back in 2007, because it gave me ready access to lots of servers. You could go to Amazon with your credit card, and just a few minutes later, you could have 10 servers, 100 servers, and you just pay for them by the hour, and things were good. But if you look at what's going on today, cloud computing is really changing how we develop and deploy applications. So a modern platform as a service offering, like Cloud Foundry, really transforms how we as developers deploy our applications. So you can, for instance, just upload your application, whether it's a Rails app, Java app, Node.js app, and Cloud Foundry just takes care of running it, managing it. Things are just a lot easier. But the really interesting thing is that all of the good features that make Spring a really good framework for development also make it really good in this new cloud computing environment. And so what I'm going to do over the next 90 minutes is just talk about how Cloud Foundry and Spring work together really, really well. So for those of you who don't know me, I'm Richardson. I actually grew up in England. I lived in Zambia for 18 months when I was a teenager, and then I moved back to England, and then 20 years ago I moved to California, hence my accent, sort of half English, half American, I guess. I got my start programming in Lisp back in the late 80s, back when Lisp and AI were very popular still. Yeah, Lisp, one of the early dynamic object-oriented languages. Eventually, I discovered Java, wrote the book Clojure in Action, which is all about how to build applications with Spring and Hibernate. That was published 6 years ago now. And then, as I mentioned, I started playing around with cloud computing back in 2007. That turned into an open source project, which then turned into my startup, Cloud Foundry, which was then acquired by SpringSource just a few months before SpringSource was acquired by VMware. So there's this great graphic of these fish devouring one another, except that the market, the value of the companies is not drawn to scale. Cloud Foundry was really more of a plankton than a fish. And so these days I'm actually at VMware, I'm a developer advocate for Cloud Foundry. And sort of in that role, I will encourage you to go sign up for Cloud Foundry, and you can use the promo code EGJUG, which will accelerate the sign-up process. And there you can upload your apps and run them and so on. And I'll show that a little bit later. Also, I've got a bag with a kind of half a dozen, some t-shirts and some USB keys with Cloud Foundry on it as well. I'll be handing them out at the end. Okay, so what I'm going to talk about is why platform as a service, why Cloud Foundry, and so on. Give an overview of Cloud Foundry basics, talk about using Cloud Foundry services, and then talk about why Spring and Cloud Foundry work together really well. And then hopefully, if there's time, I'm going to talk about NoSQL databases on Cloud Foundry and also messaging on Cloud Foundry as well. So, pretty much, for many years, apps that I developed looked like this. You had a WAR file, there was a bunch of different services. The application served up HTML, So who here builds apps that look like this? Probably quite a few people. And you know, in a way, these apps are kind of simple, you know, to develop. You just got everything inside one more file. They're simple to test. You just fire up Tomcat. You know, simple to deploy and so on. And then if you want to scale, you put Apache in front and load balance. But is it really that simple? So let's imagine that you wanted to run a performance test. Where are you going to get the hardware from? Can your company afford it? Will it take months to get those servers in-house? In many companies, it could take 3 months just to get a server installed in the data center. And then who's going to set up Apache, Tomcat, MySQL correctly? So there's sort of all of those issues, even with just deploying a basic app like that. But then to make it worse, things are changing. That means that that simple architecture that I just showed isn't really going to work anymore. For instance, we need to support mobile phones. You know, many people have smartphones. I mean, like, there's an awful lot of people here who have iPhones or Android phones. We need to support those. Users are expecting a rich, interactive user experience. So just serving up HTML to a desktop browser isn't really going to work anymore. Just doesn't really cut it. And then we have challenges with scale. Having to deal with massive loads or massive amounts of data. So it means that we need more scalable architectures. And then we also need to scale development. And it really is the case that if you're, at the end of the day, shipping a single WAR file that's got everything embedded within it, that really impedes scaling development because everybody has to deploy in lockstep. And when you push things into production, there's always the risk that you change one thing deliberately, but then you break something else unintentionally. So there's a lot of challenges there. So you end up, increasingly modern applications are just looking more and more like this. So we've sort of gone from a simple WAR file to a much more complicated architecture where, for instance, in the browser, you're running a real application written in HTML5 and JavaScript. And then you might have Node.js that's running your front-end code, and then you've got messaging integrating in with the back-end code, and the back-end is actually comprised of a whole set of independent services that can be deployed separately. And then behind those, you've got both relational databases and NoSQL databases like Mongo. And so if you look at companies like Netflix, you know, they're sort of moving into this kind of service-oriented architecture like this. So things are getting a lot more complicated. And as you can imagine, developing and testing these kinds of applications is more complicated. Not only do you need Tomcat and a database, but then you need RabbitMQ and a relational database and Node.js. You've got all of these things that need to be set up and configured properly. And then likewise, if you want to run a functional test, you need a lot more hardware in order to do that. And there's a lot more work to set things up and so on. So what's the solution to this? And in general, the solution is cloud computing, because that gives you ready access to all of these resources. But then you want to take that one step further and have a platform as a service. So instead of just simply renting Linux servers or renting Windows servers, you can just talk to your platform as a service and just say, here's my app, go run it. Just a few clicks of the mouse, or you type in a single command, and then the platform as a service takes over. And then you can scale up, scale down. And examples of that were, for instance, Google App Engine. That's an example of the platform as a service. Heroku is another one. OpenShift is a third. And then what I'm talking about today is Cloud Foundry, which is from my company. And then you've also got, in addition to making it easy to deploy apps, these platform as a services also give you other services like databases or blog storage or messaging and so on. So you don't have to worry about setting those up and configuring them and keeping them running. The platform as a service does that for you. So that's why. So let's kind of look at what Cloud Foundry does, or is and does. So Cloud Foundry is sort of many things. So one key thing that Cloud Foundry is that it supports multiple languages. So you can run Java, Spring Apps especially, but you can also run Rails applications as well. It also supports Node.js. And other people, because it's an open source project, they've extended it to run Python and PHP. So it's this multilingual platform. It also has a set of services, databases, messaging, NoSQL databases, and so on. And it's extensible. And then it runs on a variety of different clouds. So you can run it in a public cloud. You go to cloudfoundry.com where you can access it. You can actually download it and run it in your laptop on top of it as a VMware virtual machine. And you can also deploy it in your own data center as well. So you've got all these different options. So, as I said, you can go to cloudfoundry.com, upload your app, and have it running within seconds. That's a hosted version of Cloud Foundry. There's also the microcloud, which I can actually give you a a USB key with Cloud Foundry running on it. And then you can run it on your Mac on top of Fusion or using VMware Workstation. Or you can go get the source code and install it in your own data center. Like when I was at QCon earlier in the week, and I talked with one of the speakers there, and he actually taken Cloud Foundry, the source code, customized it, and was running his customers' applications on top of it. So you've got choices. And there's also these various other companies as well who have been building on top of Cloud Foundry. So AppFog have a PHP cloud. Join is supporting Node.js. ActiveState have a Python cloud built on top of Cloud Foundry. This is what it looks like internally. I probably won't really talk about this, but there's like a cloud controller that exposes the web service API that the various tools use to deploy and manage your application. I'll probably just leave it at that. Okay, so let's look at how you go about using Cloud Foundry. So, imagine you've got an application. Here I just generated one using Maven. This Maven archetype generate, you select which kind of app you want, it spits out the code of a sample app, and then you can package it up and deploy it. And when you have an app, when you have a WAR file, there's various different ways that you can deploy it. So there's a command line for VMC. There's also plugins for Maven, for Rails, for Spring Source Tool Suite, and also for Spring Brew as well. So you've got a whole bunch of different options. But this is how you use it to deploy it on the command line. So there's the command to deploy an app is VMC push, where you specify the name of the application, you specify the path to the directory that contains your WAR file, and then you specify the URL that you wish to deploy it under. And so you just type that in. And then it actually asks you a few questions. So it says, well, it looks like you're telling me to deploy a Java web application. Is that true? And you go, yes. How much memory do you want to give it? The default is 512. And then it says, do you want to bind any services to your app? In other words, does your application need a database? And I'll talk more about that in a minute. And I'll just say no, and then it just uploads your app and starts it. And so virtually seconds later, you can then access that application. So I was doing a command line hello, it just says hello world. So pretty straightforward. No more having to go purchase servers or beg or borrow servers. And no more having to figure out how to set up Tomcat. It's just all handled for you. And then if you maybe change your application, like I'm just here, I'm say editing one of the JSPs, I rebuild the app, and then I do a VMC update, and it just uploads the changes to my application and restarts it, and then those changes are immediately visible. And if I need to scale, all I have to do is just say VMC instances, name of the app, how many more instances I want. In this case, I'm saying +2, and now I've got 3 instances, so I've got 3 load-balanced Tomcats. I didn't have to figure out how to set up a load balancer, etc. Cloud Foundry is taking care of that for me. So it's all incredibly easy and straightforward to use. So that's the basics. VMC push, VMC update. If I wanted to stop the application, VMC stop. And you can also do that within your IDE, within STS, or from within Maven, and so on. Okay, so the other part of Cloud Foundry, not only can you deploy services, not only can you deploy applications, but it also has services as well. So out of the box, it supports Postgres, MySQL, RabbitMQ, MongoDB, and Redis, which are two of these newfangled NoSQL databases. And using one of these services is pretty straightforward. You know, imagine in your company if you said, "I need a database server." How long would that take? You might have to go talk to an EBA, saying, "Please, can I have a database server?" And then say, "Well, yeah, it will take a week, right?" Well, with Cloud Foundry, you just go VMC, create service, MySQL, give it a name. A couple of seconds later, you have a database server that you can use. And, okay, so how do you use it? So, how many people here use Spring? Okay, fair number. Everybody else sort of EJUG kind of thing? Oh, not good. Okay, so, you know, if you're not too familiar with Spring, you know, kind of the essence of Spring is that you define the component structure of your application. And so, whereas in EJB, you've got various kinds of beans, right? Stateful session beans, stateless session beans, and that kind of thing. So with Spring, you just define these beans that are your application components. So if you need to access a database, you define a data source bean, and you use some, like in this case, a basic data source that's basically implementing a connection pool. So that's pretty standard Spring code for accessing a database. So the neat thing about it is that this is already ready to be deployed on Cloud Foundry. So when you deploy your app, remember it said, do you want to bind any services to your application? Well, if you say yes, you then get to pick which services you want to bind to your application. So in this case, I say bind that SQL service that I just created. And then it finishes off deploying the application. And what's really cool is that Cloud Foundry sort of magically rewrites that data source definition to point to that service that you bound to your application. So you didn't actually have to make any changes to your Spring app. It just kind of, you can imagine that it went in and rewrote the definitions of your data source to point to that data, to the service that you bound to the application. So no coding changes required, even though we're now running in a cloudy environment. So that's quite nice. So if you're familiar with Spring, it actually uses a Bean Factory post-processor to rewrite the green definition. And if you're not familiar with Spring, don't worry about it. So that's the basics of using a database on Cloud Foundry. And then if you actually needed to access the database yourself, you wanted to run MySQL or the command line, for example, you can use the VMC tunnel command. And that actually basically opens a port on your machine that's connected to the database server running off in the cloud somewhere. And the actual name of the technology is Cowdicot, which is the name of a tunnel through the hills near where I live. Just coincidentally picked it after a tunnel where I live. So here I'm saying I'm creating a tunnel, and I say, I want to tunnel through to MySQL, and then it just says, well, do you want to fire up the MySQL command line? And I just say yes. And then at that point, I have MySQL talking to that database in the cloud. There's also support for other services as well, including RabbitMQ. They all use this tunneling technology. So at this point, I could dump the database, I could execute SQL statements against it, and so on. And it's all pretty straightforward. And so if I was running a testing scenario, I could create a MySQL instance, tunnel into it, populate that database with my test data, deploy the application that's bound to that database, and then run the tests, and then at the end just delete the service, delete the application, and free up those resources. So it's pretty straightforward. Does anyone have any questions so far? Yes?
Regarding the deployment, you said that it defines a number of instances. Right? Yes.
So the question is,
the question is, could it be automatic based on the CPU utilization?
So the question is, so does it factor in CPU utilization?
No, you said during the deployment for the Cloud Foundry, I defined the number of instances, right?
Yes.
I want it to be dynamic during the runtime based on the load.
Oh, okay. So the question is, will Cloud Foundry automatically scale up or down the number of instances based on the load? And the answer to that is not yet. So right now, it's you manually decide, I need 5 Tomcat instances, or, oh, now I only need 2. So you're manually doing that scaling up and down. So there isn't any auto-scaling yet. But you can imagine that that is useful under some situations. Okay, so that's sort of the basics. We've seen VMC push, VMC update, how you can create a service, bind that service to your application, and so on. So now I want to talk about using Spring and Cloud Foundry in a bit more detail. So, kind of try, because I guess not everyone here is familiar with Spring, kind of want to give a bit of an overview of what Spring's all about. So the basic idea is that with Spring, you write your application using POJOs, your business logic using POJOs, so that these just plain old Java objects that really know nothing about transactions, they know nothing about security, they're just pure pieces of business logic. So kind of analogous to EJB3 session needs, in a way. Those sort of Spring is a lot, it's older and it's actually a lot more richer and a lot more flexible than EJB. And then, so you build your application out of these POJOs, and then Spring provides 3 main mechanisms to take your components and turn them into a running application. So the first of those is dependency injection, which is a way of wiring your components together. So for instance, if you have a service that needs a data source, you would tell Spring, my service has a dependency on this data source. And then at runtime, when Spring instantiates your service, it will inject it with the data source. So the service doesn't have to go out and find the data source. It gets injected with it, either as a constructor parameter or by invoking a setup. So that's dependency injection. It's a way of resolving references. And then there's aspect-oriented programming, which is a way of achieving things, implementing things like transactions, like automatic, whenever this method is invoked, start a transaction, when it returns, commit the transaction, or doing security checks. And then you've got portable service abstractions, which are wrappers over JDBC and JMS and all the other sort of standard Java APIs. So Spring makes it easier to use. So the benefit of all of this is sort of higher developer productivity and simpler, higher quality code. And also, more interestingly, portability across different environments. So the same code could actually run in, Spring code could run inside a main program, or it could run inside WebLogic or WebSphere, or it could run inside Tomcat. Spring just sort of insulates your code from the differences of all these different environments. And the interesting thing about that is that actually carries over into the cloud, because the cloud is yet another environment. And so your application needs to be portable from your desktop into the cloud. And so the standard Spring mechanisms solve that as well. And then Spring's got some other features that help you deal with the dynamic cloud environment, integration between in-house apps and cloud apps, and also mechanisms to deal with elasticity apps that can scale up and down. So it's all these standard features that Spring has had for many years actually just help you build applications in the cloud as well. Plus, there's some interesting new features that have been added to Spring 3.1 that make it even easier to deploy applications in the cloud. So, earlier, when I showed how you deploy an app with, that uses MySQL, the Spring B definition got automatically reconfigured. Well, that's just one of the sort of number of different mechanisms for dealing with configuration that Spring provides. So it's actually the topmost mechanism. And I'm just going to walk through all the various other mechanisms that Spring provides for working in a Cloud Foundry environment. So when Cloud Foundry deploys your app is actually running as a separate process, a Tomcat process, or a Rails process, or a Node.js process. And then there are a couple of different environment variables, so system variables that tell that Cloud Foundry sets with information about your application. So for example, there's a VCAP application environment variable that has various bits of information in it, like what URL is that application actually running on? So for instance, if the app needed to generate some HTML that points back to it, it can get that information from VCAP application. Or if the application needs to know what port has been assigned to it, it can get that information out of the VCAP application as well. Though often you don't need to worry about that kind of thing. And then the other environment variable is VCAP services, and that has all of the information about the services that are bound to the application. So in this case, this app has one service, the MySQL database, and that's got useful information like what's the host of the database, what's the port, what user ID and password should the application use to access that database. And I should have said this is all JSON. If you use JavaScript, you're familiar with this. So the struct format of this is JSON. So you can imagine that the auto reconfiguration that I showed earlier actually goes and uses this information to build up to rewrite that data source definition and plug in the host, port, user ID, and password, etc. So if you wanted to, you could write Java code that simply got hold of those environment variables, parsed the JSON yourself, and pulled out the values that you need in order to configure your application. But that would be pretty unpleasant, right? It's just a lot of messy programming. So one of the things that's provided by the Cloud Foundry Java runtime is the Cloud Environment class. And that's just a nice wrapper that gives you access to the information in those environment variables, but in a nice Java-friendly way, so you don't have to do any low-level coding. So on this slide, it's showing how you can get hold of the properties that are derived from from all of that information. So you get properties about the MySQL service that you've bound to your app, for example. And then you can get hold of the application instance info to find out what port your app's running. So these are just wraps those JSON environment variables. It also has APIs for sort of higher level to say, give me information about this MySQL service, and I know that it's an RDBMS service, and I get back an RDBMS service info object that I can then just describes that relational database. So it's sort of a higher level API. And then I could actually take that and create a data source from it using this RDBMS service creator class. So I get my service info by looking up the service by name, and then use the service creator to actually make a data source. So it's sort of, slightly higher level. But if you're using Spring, then you'd probably really want just some B definitions that represent the various services that are bound. So there's a cloud namespace. So we're extending the XML, the Spring configuration, by defining a Cloud Foundry specific namespace. So let's look at an example of that. So that auto reconfiguration that I talked about earlier is great if there's just one database that's bound into your app, and you don't really want to have any control over the connection pool configuration or anything like that. But if you do need control, then you can use the cloud data source XML element to define a data source to access that bound service. So you specify the service name, and then you can specify properties like the connection pool size and so on. So that piece of XML defines a data source that can then get injected into my data access code. So that gives you a very explicit control, like I want to access that service, and I want the connection pool to have these properties, and so on. So that's one thing that it provides. There's also a cloud properties element that sort of exposes those properties in the Spring application context so that they can be referenced by placeholders like this. Either here we're accessing it in some Java code, or you can access it from XML, so you can get values out of the cloud environment and inject those values into your Spring Boot. So that's sort of the basics of the configuration. But then we get into an interesting issue. It's like, okay, so imagine we use the cloud namespace. But I still want to be able to test my application on my desktop. I don't always want to run it in the cloud, because I can do interesting things on my desktop, like remote debugging and that kind of thing. So the challenge we have is, well, how do we build an app that runs both on my desktop, but also in the cloud? And the solution to that are these new Spring 3.1 profiles. Has anyone looked at Spring 3.1 by any chance? Okay, a few. Lots. They sort of added some really interesting features to it, specifically to support Cloud Foundry. So the idea behind profiles is that you have beans that belongs to specific profiles. And then at runtime, one or more of those profiles are active. And when a profile is active, its bean definitions are active as well. And if a profile is not activated, then those bean definitions are not actually used, they're basically ignored. And so that means that you can run your application with one profile, get one set of bean definitions, run it with a different profile, get a different set of bean definitions. So you can imagine that on my desktop, I'm going to use one set of bean definitions, and then in the cloud, I'm going to use the cloud namespace bean definitions. And then one sort of wrinkle on that is that by default, if you don't actually activate a specific profile, a profile called default is the active one. So what that means is that you end up writing bean definitions that look like this. And you can see that what we're doing is we're nesting bean definitions, or cloud and namespace definitions, inside a beans tag that has a profile attribute. So we're saying up here, here's the default beans, here's the default profile beans, which is just a regular data source pointing at my database on my desktop. And here, when we're running in the cloud, we've got this cloud namespace that's automatically activated by the Java runtime when you're running on Cloud Foundry. We're going to use this cloud data source to access the bound service. So by using these bean elements with profile attribute, we can write an application that works in both places, quite straightforward. And you can imagine extending this just so this obviously has utility outside of Cloud Foundry. You can say, in my dev environment, I want these sets of beans in my prod environment because I'm obligated to run inside WebSphere. Then use my JNDI lookup mechanism to go go find a WebLogic data source. So the profiles are useful in sort of independently of Cloud Foundry. And it just simplifies a task that up until now was quite tricky. You know, different beans in different environments. It's not actually been that straightforward with Spring. Then another sort of way of using this is, for a while now, Spring has had Java-based configuration. You know, people have always complained how Java development or enterprise Java development has required you to have lots and lots of XML. And so that was true of Spring, where you needed XML to define all of your beans, or do some configuration at least, and then that got replaced by annotation-based configuration to a certain extent, but you still needed some XML. And now with Spring 3.1, you can actually use Java-based bean definitions to define practically all of your beans. And there you can use the app profile annotation to say, these bean definitions are active for this particular profile, those bean definitions are active for that profile. So it's covering Java config as well. So you've got a lot of different mechanisms. You've got cloud environment, you've seen the cloud namespace, you can use profiles to achieve portability. And then one last thing is, well, my app running in the cloud, I might actually have my dev environment, I might also have my test environment and my prod environment as well. And maybe my app needs to access other external services, different services like a payment gateway in production and a dummy payment gateway in the QA environment. So the challenge is, well, how when I'm deploying on Cloud Foundry do I configure the app with these external dependencies? And the secret here is to just set up an environment variable using a command like bmc app and env add that just says this environment variable for this app should have this value. And then in my Java code, I can access it using system.getEnv, or I can use a Spring expression language expression to get hold of that environment variable. So this helps with configuration. Any questions about that? Yes?
Profiling is the same as the Muffin profile, or the same concept of Muffin profile? Or?
Well, is that multiple profiles?
Profile in Muffin. When I'm using Muffin, I can't find the profile.
Oh, so you're asking about Maven profiles, right? I mean, it's an analogous concept, right? Where you've got one Maven, you can configure Maven with one profile to do one set of behaviors, and a different profile to do another set of behaviors. So it's the same concept, but entirely different implementation. By the way, I'm keeping track of who answers questions, because I have some Cloud Foundry t-shirts I'm giving out at the end. So, incentive. Okay, so that's where, we've looked at the basics, we've looked at using services, and we've looked at Springs and the configure and how to go about doing configuration. So I want to go off and look and kind of talk about two really interesting sort of topics. The first of those is NoSQL databases. These newer, trendy, non-relational databases, because they're supported quite well in Cloud Foundry. And then at the end, I'm going to talk about building asynchronous applications using RabbitMQ and running those on Cloud Foundry. So analogous to a JMS program. So just out of interest, who here has heard the term NoSQL? Okay, this will be interesting. So Cloud Foundry supports Postgres, MySQL, two standard relational databases, but it also supports Redis and MongoDB. which are examples of these what are called NoSQL databases. So they're actually non-relational databases. And actually my next talk is about NoSQL databases in lots and lots of detail. So now, for now, I'm just going to kind of talk about it very briefly. So, relational databases are good, right? For the most part, we've all been happy using them for 20, 30 years. But the past couple of years, or 3, 4 years, many companies, especially ones operating at large scale, like Facebook, Amazon, Google, etc., have sort of found a whole bunch of issues with relational databases. Namely, they don't scale very well. Or for certain use cases, they don't have the best performance. Plus, there's the general problem where I've got my rich domain model, nice set of objects and relationships between them, and then, well, how do I map that to my relational schema? There's this object relational impedance mismatch problem. And then, what happens if I've got some entity in my system that has a varying number of attributes? Well, that doesn't work too well with tables, right? Because tables have a fixed set of columns, whereas if you've got varying numbers of attributes, well, that doesn't really fit with a fixed set of columns. So there's sort of these problems of relational databases. And as I said, I'm going to go into this in a lot more detail in my next talk. But so these so-called NoSQL databases have emerged to address these problems. And so for certain use cases, they can give you much better performance or incredible scalability. There's some of them, for example, you can cluster them and you just keep adding servers and you just keep scaling and you have hundreds of database servers all operating in one cluster, which you can't really do with a relational database easily, or cheaply, I should add. So they've got some real, and they're also good at dealing with storing richer data or unstructured data where you've got varying attributes and so on. But you kind of have to give up a few things. So like ACID transactions, you tend not to have those, for example. And then there's issues with, you might make a change, and then you try and read the data, read what you changed, and maybe you get back the old data. It might take a while for the data to replicate amongst all of the servers. So they tend to be kind of different, but on the other hand, they give you incredible benefits for some use cases. And so even though, for a long time we just thought relational databases are good for everything, we're actually moving to a world where you're going to build applications that use a mixture of different databases, like different modules of your app will use the database that's best suited to it. So if you need ACID transactions, then you use a relational database. Whereas if you have a social graph, for example, then you'll use a graph database like EGJUG. Or if you've got some complex data structures, maybe you'll put that in a document-oriented database. So you end up moving to a world where you're going to mix and match. And to help with that world, there's a Spring Data project, and its goal is to provide, bring the value proposition of Spring, like productivity, portability, to this world of NoSQL databases. And so it's got template classes for various NoSQL databases like Redis and MongoDB, and can map between, take the Java objects and persist them in a NoSQL database and get them back out again. So the goal of Spring Data is to help to simplify your NoSQL code in the same way that it simplifies your JPC code. So just to give you a flavor, set some context, I'm just going to talk very briefly about MongoDB. As I said, I'm going to go into this in a lot more detail in my next talk. So MongoDB is a document-oriented database. And when I heard the term document-oriented database the first time, I didn't really know what that meant. XML, Word, what's that? But basically, a Mongo document is a JSON object. In other words, it's a set of name-value pairs where the values can be scalar, like strings, numbers, or the values could be an object, so it's sort of recursive, or the value could be a list of values, which could be a list of strings, a list of objects, or a list of maps. So it's rich, recursive data structure. And it's also schemaless. So if one entity has 5 attributes, another entity has 8 attributes, it's not a problem. They can all just be stored as documents. It's also incredibly fast. You can just, I mean, it's like ordered, in some use cases, it's just orders of magnitude faster than a relational database. And it's scalable. You can shard your data and replicate it all transparently to the application. So here's an example of a document. So all my examples are actually tend to involve food, because I like restaurants and eating and so on. So here's a document that describes one of my favorite Korean restaurants. So you can see we've got a name, a type, a service area, which we don't really need to talk about now, but it's an array. And then it has an opening hours, which struct attribute, which is a list of objects, and each one describes a particular opening hour of the restaurant. So in this case, it says it's open on Wednesdays from 5:30 until 10:30. And then we've got an ID of attribute as well. And these can be up to like megabytes. You know, they can actually be megabytes in size, so massively complex structures. But they're actually written as like a stream of bytes on disk, so it's very fast I/O to put them in the database to get them out. Whereas you can imagine mapping something like this to a relational database. You'd map it to many tables, and many rows and many tables. And when you're saving an object, you know, you're actually doing a lot of random I/O. When you're pulling an object out, you're doing a lot of joins, or a lot of SQL statements, which ends up being quite expensive and not very performant. So Mongo is like a big graph of objects that just gets stored very efficiently in the database. And then a set of documents forms a collection. So we've got a restaurant collection. It's like a table in a way, but different documents can have different structures. It's not every row has to look the same kind of approach. So you have some flexibility, which is good for dealing with semi-structured data. And then a set of collections forms a database, kind of like a schema in the relational world, and a server can have multiple schemas. So that's sort of Mongo in a nutshell. And its primary use case is a way of doing lots of high-volume writes, like logging. You just want to keep pumping data into the database. Or applications where you're storing complex data that would be just plain hideous to store in a relational database, or where you're storing semi-structured data. And there's quite a few companies that are using it. So Spring Data provides a Mongo template. So if you use Spring, you probably use the JDBC template or one of the other template classes. So Spring Data for Mongo has a Mongo template that's another wrapper on top of the Mongo API. It just gives you a nice, easy-to-use API and it does things like translate Mongo exceptions into Spring Data access exceptions, so you get uniform exception handling. And then it also knows how to map your objects into Mongo documents and back again. So it takes care of that. So, you know, here's an example entity. We've got a restaurant, and that's got various fields, including a set of menu items. The menu item has a name and price. It's a pretty simple structure. So here's the data access object that's got two methods: add, that persists a restaurant in Mongo, and then find by name, that loads that finds all restaurants with a particular name. And you can see it's pretty straightforward. Just using Mongo template save, name a collection, entity that I want to persist, save it in the database. And then to do the query, I'm just using a find method where it takes the collection name. I'm building up a little query, so using this query helper class where name is restaurant name. And then that's the target class that I want to, so it's going to find those documents, iterate through them, and map each one into a restaurant. And so when I save a restaurant, it looks like this. to actually, get this to work, you need a bit of Spring configuration. So we've got some, up here we've got some B definitions that define a MongoDB factory, which is kind of like a data source. It's analogous to a data source, so it represents a connection to a Mongo database. So in the non-cloud default profile, I use the Mongo namespace that comes with Spring Data to access my locally running Mongo database. And then in the cloud case, I use the cloud MongoDB element to access the Mongo service that's bound to my application. And then I inject the Mongo factory into the Mongo template, and that Mongo template gets injected into my data access code, and I'm good to go. Okay, so how do I create a Mongo service? Well, once again, it's pretty straightforward. So if I wanted to, I could do the exact same thing that I did with MySQL, where I just said VMC create service Mongo, and that would give me a running Mongo instance. But what I can do instead, I've got a couple, is actually when I deploy my application, it says, do you want to bind to a service? And I say yes. And then it says, do you want to bind to an existing service? And I say no. And it says, which service do you want to create? So at this point, while I'm deploying my app, I say, I want to create a Mongo database. The Mongo database is called Mongo1, and so it binds it to the application, deploys the app, and I'm good to go at that point. And then, I'm using curl on the command line. I can then just access my Mongo application running inside Cloud Foundry. And then likewise, if I need to, I can tunnel into that Mongo database and use the Mongo command line tools to access that database. Look at, run queries, dump the data, load data, and so on. And it's similar to support for Redis as well. So that's kind of like Cloud Foundry and NoSQL in a nutshell. And as I said, I'm going to talk about NoSQL in lots and lots of detail in my next talk, but I guess it's at 4:30, so I will encourage you to come to that. But question, you only get one T-shirt, by the way.
Thank you. Just asking about the validation of the Java, the JSR, which is working with Hibernate. This standard, can I use it with NoSQL? For example, I need to make some validation on
oh, yes. So the question is, what about the validations mechanism that works with Hibernate? Can I use that with NoSQL? And probably right now the answer is no, at least in the context of Spring Data. But I think Hibernate is doing something in the NoSQL area as well.
But there is a way to make some validations on NoSQL data types, or I cannot do this validation.
You would, basically, I mean, you have to code that yourself. There's a question. Yeah, I'll say that again. Oh, yeah, could I use the microcloud as my testing environment so that I don't need to use different profiles? Kind of like yes and no. So yes, the microcloud, run it on your desktop, and for instance, you have, in the new version, you've got remote Java debugging, so it basically behaves like a locally running Tomcat. So yes, if the only testing you were doing was to just deploy your app into the microcloud, then you wouldn't need to define any profiles. And so that would be quite straightforward. But on the other hand, it's usually a good idea to have these integration tests that you would run just within Eclipse or run within IntelliJ And for those, you want whatever running in there inside your IDE, not inside Cloud Foundry, but they might need to access services. And for those, you actually really would have to use profiles because they're running in a different, they're not running inside Cloud Foundry. Okay, does MongoDB? I can't remember whether it does or not. I know that Grails has support for Mongo, but I can't remember whether Spring Boot has support for Mongo. Are there any GPA providers for MongoDB? Off the top of my head, I'm not aware of any, but I tried Googling to see if because there's all these open source projects and so on. Well, I think, well, it depends what you mean exactly. So, one of the things that I'm not talking about today is the Spring Data actually has what's called cross-store persistence. So you can have a JPA entity that's mostly being stored in a relational database, but then you can say this field should be, or these fields should be stored in Mongo. And so when you do entity manager.persist, it writes to a relational database and writes to Mongo as well. So that kind of sort of gives you, but it's not quite the same as what you're asking. Yeah.
Also, can I use the transaction management of Spring with Mongo?
Oh, yeah. Can I use Spring transaction management? Well, that's one of the things you tend to have to give up in a relational, in a NoSQL database of transactions. Like the scope of a transaction is the save or update of a single document. So you can't have multiple database operations within a transaction. So one last question, and I should move on, but come to my talk later, and I have more time to answer the NoSQL questions. But yeah.
You showed an example to increase the number of Tomcat instances. I'm asking, how do you actually manage this to increase them? When you increase the number of NoSQL instances, how do you make sure you price to the right?
Oh, okay, yeah. So the question was, well, about increasing the number of instances. And so there's only one instance of the database. So what you can, you're not scaling that, you're just scaling the number of Tomcats instances or the Rails or Node.js equivalences. So there's one database, and then 3 Tomcat instances of pointing at that one database instance.
So database level, but after how to size
in terms of if you needed multiple, but currently Cloud Foundry is in beta, so yeah, so if you needed multiple database instances, you'd have to create multiple database services, VMC create Mongo Service 1, VMC create Mongo Service 2, kind of thing. Yeah, but yeah, I'm happy to talk more offline about that. So, I know that I'm between you and lunch, so which is starting kind of soon, but we started late. But I'm just going to talk briefly about asynchronous architectures. So, we've talked about Postgres, MySQL, talked about NoSQL, Mongo, Redis. Then the other service that Cloud Foundry provides out of the box is RabbitMQ, which is a messaging broker. So kind of analogous to JMS, but not quite the same. So kind of what I want to talk about in this part of the talk is, well, what is RabbitMQ? Why would you want to use it? And how would you use it? So, applications have used messaging for a long time, right? JMS has been around for pretty much the beginning of enterprise Java. And one use case for it is application integration. So application A needs to talk to to application B, but in an asynchronous fashion, so we just sort of use a message. So A will send a message to B and fire it off, forget about it, and so on. So that's one use, but a sort of more interesting case is with these modern application architectures, we would actually use messaging between the different components of the application. So, for example, we've got a front end that's running, separately from all of the back-end components. So we've got a storefront UI, but this is e-commerce, so the user places an order. And then the front end, at that point, just basically publishes an order placed message on the message bus. And then from then on, the back end can take and process that order, do the inventory checking, do the shipping, checking whether the customer has enough credit, for example, to buy that order. And the nice thing here is that, if any of these back-end services go down, the storefront doesn't care. It can just continue, it just places the orders and then they get queued up within the message broker. And then when the back-end is available again, it will just start processing the messages. So we've sort of decoupled the front end from the back-end processing. And then the messaging can always just be good from a usability point of view, user experience point of view, improves the availability of the system. Then also, it actually, the messaging broker just can smooth out traffic spikes. So if the storefront got incredibly busy and the back end couldn't keep up, then the messages would just get queued up within the message broker and eventually it would catch up. So that's quite nice. So it just sort of fits well. So the idea is you've got different components of your application just firing off messages asynchronously to one another. And that's actually how Cloud Foundry works internally as well. All the different pieces communicate via a message broker asynchronously. So that's sort of why messages. So messaging's been around for a while. JMS, we've used that for. I remember programming in JMS back in 2003 or something like that. So RabbitMQ is like somewhat different than sort of JMS. It's actually got a slightly different messaging kind of model as well, though equivalent model. But what's really interesting about it is that RabbitMQ is this open source message broker, and it's just designed to be robust and high performant and so on. But sort of one really interesting characteristic about it is that it actually supports a standard messaging via protocol. Whereas if you think about JMS, if you want to use JMS, where you've got to have a Java library that matches to a messaging broker. But with 20 minutes. Whereas with RabbitMQ, it talks AMQP. So it doesn't care about the client that's talking to it, just as long as the client can speak AMQP. So it's a standard sort of high performance messaging protocol. And it's sort of, people talk about how you can run thousands, process thousands of messages per second using AMQP-based message brokers. So it's sort of a different approach to the client library-driven JMS approach. So Spring has a separate project called Spring AMQP that it's got wrapper classes that basically simplify the processing or simplify applications that need to send and receive messages. So there's an AMQP template that's got methods like send or receive. And underneath it's doing all the low-level sort of AMQP API type things in order to send or receive that message. And then there's also a listener container that's equivalent to message-driven beans in sort of EJB space as well. So you can just listen to messages on a queue. When messages arrive, a method on one of your components will automatically be invoked by the listener container. So here's some example code. So we've got an AMQP template, we've got convert and send that says send this message to that exchange, with that routing key, for instance, or receive and convert, which says read a message from that queue and give me back a string. So that's a basic low-level API, which works, and you've got complete control over what you can do, but it's a very low-level API. So another project that Spring provides is Spring integration, and that implements. There's a book called Enterprise Integration Patterns. There's a really good book that just describes all these different patterns for messaging. And Spring integration basically implements those patterns. So the idea is that you've got producers and consumers that read and write messages via channels. And then channels can have filters or can have endpoints that can transform those messages in some way. So you've got channels, so it's like a pipe connecting producers and consumer. And then you've got these endpoints that will write a message to a channel or read a message from a channel. And then there are these different endpoint types. So you can have transformers that take a message, transform it in some way, and then write it to another channel. We have a filter that takes a message, it examines the message, if that message matches some criteria, it will pass it on, or otherwise it will discard it. There's a router that examines that message, and figures out which of many messaging channels to split it, to send it to. What else do we have? There's also a service activator that listens to a message. When a message arrives on a channel, it invokes a method on one of your components. So it's kind of the glue between the messaging world and your application code. And then there are these various channel adapters that can say read from an external source, which could be an ActiveMQ or AMQP queue, or it could be some email server, so it gets that message, puts that message into a channel. You can even have a inbound channel adapter that pulls the directory, looking for files to get dropped into that directory, and then just grabs that file, writes it as a message into a channel. And then conversely, there are these outbound channel adapters that read messages from a queue, or from a channel rather, and then send them to some external place, which could be send them off as an email message, could be write them to a RabbitMQ, could be write them out to a file. So, if you're doing file-based application integration, which is still pretty common. So basically, you've sort of got this plug-and-play mechanism where you sort of declaratively define the plumbing between all your different components and your external systems, and Spring integration just creates all these pipes and filters to wire everything together and process the messages. So I'm going to talk really briefly at a high level about how this e-commerce application could use Spring integration. So the idea is you've got your storefront, you've got your billing application that's doing credit checks, you've got an inventory application that's sort of checking to see whether items are in stock, and then you've got your shipping application that's kind of conceptually shipping the app. So the storefront places an order, sends a message to RabbitMQ. The idea is that the Spring integration logic running there does the inventory check, does the credit check, and then passes the results of that off to the shipping application, which, if this was a real app, would ship product to the customer. So, this diagram shows how it works, how Spring integration is actually used in this case. So the store UI writes to a message endpoint. So that's kind of the interface, that's the way it writes or sends a message into Spring integration. And the message endpoint just puts the message onto an order channel. So the store UI at this point has no idea how that order message is processed. It just basically writes it to a message endpoint. And then the order channel takes over, and then there's a filter, or transformer rather, that transforms the order object into a JSON document, because that's sort of a nice portable format, and that gets written to an AMQP out message channel, and then there's an AMQP outbound gateway that takes that JSON message and publishes it to RabbitMQ. At this point, the store UI has no idea that any of that has happened. It's just basically written a message, sent a message via a message endpoint. But then there's all this XML configuration, and now actually Scala DSL configuration that sets up all of these channels and transformers and outbound external gateways to take that order, turn it into JSON, write it to a RabbitMQ queue. So that's what happens in the storefront. And then what goes on inside inventory is sort of a bit more involved, where we've got an inbound gateway that reads the message from the AMQP queue. So we're getting the message from RabbitMQ, and it writes it to the inventory message channel, and then there's a transformer that takes that JSON, converts it back into an order object. And then we've got an order object, and then two things happen. The first of them is that we need to do a credit check. And the way that works, it actually uses what's called an enricher. That's an endpoint that really, as the name suggests, enriches the message, like adds some extra data to it. And what it's doing in this case is actually setting a flag to say whether it passed the credit check or not. And the way the credit check is actually performed is that it actually writes a credit check message to the credit check service activator that invokes the credit service. So the credit service returns a Boolean value credit check passed or not. And that ends up getting set as a flag in the message by the credit check enricher. And then there's also an inventory check as well, and that's also involves this enricher that sets a flag to say yes or no, this item is in inventory. And then the way the inventory checking works is the order gets sent to the inventory router, and then there's a inventory router message channel, and then there's a router that says, well, if it's a widget, check it. Use this flow for checking. If it's a gadget, use this flow. So you just, at a high level, you just say, well, it's looking at the message and then sending it to one inventory service if it's a certain kind of product, or sending it to a different inventory service if it's a different kind of product. And then the result, yes, no, it's in stock, gets added into the order, which then gets put into the inventory AMQP out message channel, turned back into JSON, and then sent off as another AMQP message over RabbitMQ. Key thing again is that all these services that are invoked, you know, your business logic, completely unaware that there's all this message flow happening. They're just doing credit checks, inventory checks, and returning Boolean values. And then it's Spring integration through the XML configuration that's wiring everything together and routing all of these messages. Yeah?
Small question. Are these services asynchronous services or synchronous?
Oh, good question. So are these, well, so are they asynchronous or synchronous services? And they're actually synchronous services. So even though there's messaging happening, it's basically what's happening is a message gets sent that ultimately causes the service to be invoked, and then the return value of that service is actually sent back asynchronously as a reply message. So it's sort of mixing, so it's kind of asynchronous, kind of synchronous. Oh, exactly, yeah. I mean, the front end is just firing off order. And so that order is, once it's been written via the message endpoint, store UI is just done. And I know that, I mean, this is somewhat of a contrived example, and maybe you actually want inventory checking to be online. But, I mean, I've done things where, I've gone to some, big online stores where I placed an order, right? And then I get an email 5 minutes later saying, sorry, your item is back ordered. And so you'd like to think that a lot of this processing is happening in real time, but there's often very, architectural advantages to just saying, thank you for your order, we'll get back to you in a minute, as to whether we can actually ship this product. Okay, then, shipping is a similar thing where, inventory service writes it to AMQP, then shipping gets the message, and, once again, it's a channel, convert the JSON message into an object, and invoke the shipping server. So, yeah?
The process of sending a message and the consumer takes a message and the reply back synchronously is the job of queue itself. So where does the Spring integration take place?
Well, okay, so a lot of this, all of those channels are actually in-memory objects. So remember, so channels themselves are just in-memory objects. You can imagine just some kind of, well, basically glorified Java queues, right? So it's only, RabbitMQ is only involved if you explicitly have inbound and outbound AMQP gateways. So all of what's happening in here is actually very much Spring integration. I can see people are hungry. So, fortunately, okay, so just couple more minutes. So, okay, so that's sort of the basics of Spring integration, RabbitMQ, and so on. And then it's like, well, how do you use this on Cloud Foundry? So once again, you just create a server, you create a service, you've got some basic configuration using cloud namespace, or if you're outside of Cloud Foundry, you've got the Rabbit namespace. You've also got Caldecott support, so you can tunnel into RabbitMQ and use RabbitMQ tools for your desktop. And that's pretty much my talk. So in summary, platform as a service, great. Cloud Foundry, great. Spring, great. Cloud Foundry plus Spring, it's really good. And so I just sort of encourage everybody to go to cloudfoundry.com, sign up, and download the microcloud if you want, and just play with this technology. So thanks for listening, and I hope you found it useful. Yeah, I'll take it. So there's support for other integration frameworks. Well, as far as Cloud Foundry is concerned, it doesn't know about Spring integration, right? So the only thing that's really happening is there's some support and it's just basically binding a RabbitMQ into your application. And then at that point, whatever your application does is entirely up to your application. So if you wrote a Java application to use Camel that was connected in with RabbitMQ, that would be fine. If it was a Rails app that was connected in with RabbitMQ, that would be fine too. That's sort of none of Cloud Foundry's business.
An announcement to say, now it's lunch break, and there is a competition called Java Tricks. Will be at ITS booth, and you'll be granted on live interview. Thank you. Continue on the questions. Sorry about that.
Yeah, but feel free to leave if you want lunch. Okay.
What about applying Spring security on Cloud Foundry?
Oh, so what about Spring security on top of Cloud Foundry? I mean, once again, that's an application issue. So if your apps just using Spring Security, you know, Cloud Foundry is happy with that. It doesn't really, it's not really concerned. Yeah. So basically you're asking, well, well, sort of the short answer is RabbitMQ has like dead letter queue concept as well. So right, yeah. So yeah, I mean it's sort of a standard messaging pattern / feature. So yes, that is available. Yeah.
When Cloud Foundry be available for production?
So the question is, when will Cloud Foundry be available for production? So the only thing I mean, in terms of cloudfoundry.com, all I can say is sometime in the future. You know, the date hasn't been announced. But having said that, like a couple of days ago in London, I was talking with someone who has taken the Cloud Foundry source code, built his own PaaS in-house, and is using it in production today. So it's sort of cloudfoundry.com at some point will become production ready, but clearly the actual code base that you can just download today is already being used in production.
All right, thank you. When you are uploading a new version of the application, when you're pushing updates that you've made locally to the application, are you pushing the whole application, or are you using some diffing service, something similar to what Git or HG does, to push the changes only?
Yeah, actually that's a really good question. So if you think of an app, so if, like a WAR file is comprised of a set of files, right? And apps, whether it, you know, in Rails, you don't have a WAR file, you've just got a directory of source code, it's a set of files. So basically, what the command line, what the tools do is say to Cloud Foundry, have you seen any of these files before? And so if someone, for instance, had uploaded a WAR that had a jar file in it, that jar, no one else ever has to upload that jar file again. So basically, when you upload a WAR file, even if it's the first time for you, that upload can end up being really, really small. And then the next time you upload the modified version of that WAR file, it's just a very tiny set of changes for sure. So Spring jars, you never have to those don't get uploaded because someone else has already uploaded them before. Yeah.
Okay, thank you.
So
my last question was about Scala support. You've mentioned Scala in your presentation, so how much support are you providing for Scala?
Okay, yeah. So Scala, the Scala Lift framework is supported by Cloud Foundry. So if you deploy a Scala Lift application, it's going to say, oh, looks like you're deploying a Lift application, and then does Lift, I don't know Lift, and then does Lift specific things to do configuration and so on.
I have a question about there's version controlling for the application I'm deploying. For example, can I revert my changes or something on the cloud server?
Oh, yeah. So, is there any kind of versioning? And the answer to that is no. If you wanted to, I mean, you can do things like, you could, instead of updating an application in place, you could actually just push a brand new application and keep track of versions that way. And then there are ways of manipulating the URL mapping. So I've got some URL, I can actually remap that URL to that newly deployed application if I wanted to. So you can do sort of life cycle management that way. Yeah. Oh, sorry. Changed my mind. You're running back and forth.
I'm asking about portability. If I have an application, a Spring application, can I put it on Cloud Foundry? And the opposite, if I have an application on a Cloud Foundry, can I have it on a simple Tomcat?
So yeah, the question really is about portability back and forth. So if you have a straightforward app that, say, just has one data source, that will almost always just automatically work on Cloud Foundry, right? Because it will just do this auto reconfiguration thing and change the Spring data source B definition. If you then get into the issue of more complex configuration with the cloud namespace, then at that point you really want to use profiles so that you have a cloud profile and the default profile so that it works in both places portably. But effectively, once you know what you're running in Cloud Foundry, when you deploy the Java app to Cloud Foundry, you're running on Tomcat in a pretty standard environment. You know, there's not sort of weird stuff going on. I mean, obviously there are limitations, like in Cloud Foundry, you shouldn't really be writing to the file system because it's sort of, you know, cloud files don't really go together too well.
Is there services for Neo4j and etc.?
There's support for Neo4j. I believe someone has contributed a patch to Cloud Foundry to support Neo4j, but that's not available on cloudfoundry.com.
Is there any way I can use Neo4j?
Oh, is there any way? I mean, in theory, you sort of get into issues where Neo4j wants to write to the file system, which would kind of be allowed, but then it's sort of an embedded database. So you might be able to accept the whole file system thing is tricky.
Okay, I found something called vFabric when some services listed. Was particularly safe to be supported for vFabric.
Oh, I mean vFabric, I mean that's another sort of Spring source family of products that's somewhat separate from Cloud Foundry. But like for instance, Spring Data actually supports Neo4j. So I guess we should wrap up. I mean, I happily take questions sort of offline, but you know, I want to thank you for listening. And so if you ask a question, the first 4 people who ask questions can get a t-shirt, though it might not be in your size. And then I also have some USB keys with the micro cloud on as well. So once again, thank you.